And what questions you guys want to see from 8.1a? What? Number one? Yeah, so 1 and 23. Alright, so 1, we got dy dx equals x over the square root of x squared plus 1. And we want to select the correct antiderivative. So, for this one, when you go, guys, am I going to teach or not? So you go to integrate, you got dy equals x over the square root of x squared plus 1 dx, and you go to integrate this. And what method should you use there to integrate? A u sub. So u is going to be x squared plus 1, so then du is going to be 2x dx. What do we need to put in there to make this work? 2 and a 1/2 on the outside. So then you go to integrate and you have 1/2 times the integral of 1 over what? Root u. So u to the negative 1/2 du. And then when you integrate this, u to the negative 1/2 becomes 2u to the positive 1/2, and that's just u to the 1/2 plus c. So you're looking for the square root of x squared plus 1, and that's options B. So option B was this, root x squared plus 1 plus c. There's your y. Ta-da. So where were you, Noel? Make sense? All right. And then we had a question for 23. So 23, we have the integral of x squared over x minus 1, right? Okay.
Long division.
Yep. How do we know long division?
Because it's the big John divided by the little John.
Yeah, you got a big John divided by a little John. So since top degree is greater than bottom degree, probably long division is the way to go here. And because the denominator is multiple terms, it's not like you can just divide this out, x squared divided by x and x squared divided by negative 1. If it were upside down, that would be fine. But with multiple terms in the denominator, that's really not allowed. You have to do long division. So, or you could probably try u substitution, and it will work. That's the Bethlehem method. She hates long division, so she'll always do a u substitution to try to avoid it if possible. But I'm going to recommend long division.
You after the long.
Then that allows you to break it apart into multiple integrals. So x goes into x squared, x times, x multiplies, you have x squared minus 1x. You subtract all that, you get positive 1x plus 0. Then you do it again. X goes into 1x one time, 1 multiplies that, you get 1x minus 1. You subtract, you get positive 1. So this turns into x plus 1 plus the remainder 1 over x minus 1. So we're now integrating this mess, which is a lot easier because now you can integrate each of these pieces individually. So the x turns into 1/2 x squared. The 1 turns into x. And the 1 over x minus 1 becomes natural log of absolute value of x minus 1. And that's it. So if you can do your long division, then the resulting quotient and remainder is pretty easy to integrate once you got it. If you did the Bethlehem method and you did a u equals x minus 1, sure. And then du equals dx, and then you got to deal with this x squared. So that's where you go into the u versus x relationship and isolate the x and say u plus 1 equals x, and that goes in there for x and it gets squared. So you now have the integral of u plus 1 squared over u du. You could distribute that out, divide everybody by u, and then integrate in terms of u. And it works out pretty well, actually.
Long are you recording? 2.
Yes.
Would that be easier than long division? Or not easier, but like more simple? Or would it be?
I think it'll be about the same. Like, you have to come up with, this part's easy, this part's a little bit clever, then you got to distribute this out, and you'd have u squared plus 2u plus 1 all over u. So when you divide that, you have u plus 2 plus 1 over u to integrate. And that's very easy to integrate it. So it's not any more difficult to integrate this. It's just a matter, it's like pick your poison. Do you want to deal with this process, or do you want to deal with a long division process? And then you got to remember to switch back to x at the end.
And on the AP test, are they ever going to be like, you must use long?
No.
So you can use whatever.
You can use whatever method you like, as long as it works, and as long as, like, if it's on the non-calculator, obviously you can't use a calculator. But no, the AP exam, maybe I can see them saying use shells or use washers. But even then, I would imagine it's probably like not so much as a, we really want you to use shells, but a, you better use shells because washers ain't going to work sort of thing. But even that, I think that they kind of leave it up to you as how you attack it. So the AP exam, they're not going to say, integrate this using long division. They're going to say, integrate this. How you do it is up to you. Any other questions from the homework, Olivia? 8? Yeah. So 8, it's a little yuckier. All right, so 8, we have integral of 2 over, what is it, a 4?
2 over 2 minus 1 squared plus 1.
dt. All right, arcjohns. How do you know arcjohns? Yeah, we have something squared plus a constant. So that's kind of telling us there's a pretty good chance of an arcjohn. If you had to choose arcsine, arctangent, arcsecant, what's your best bet? Arctangent, because no square root. So think arctangent, and for arctangent, remember you're looking for du over u squared plus a squared, where a is a number and u is your variable piece. In this case, what's u going to have to be?
2t minus 1.
2t minus 1. A is going to have to be 2. Du is 2 dt, and you're like, hey, that actually works out beautifully for us. So we can, this fits right into our arctangent pattern. So once you see that, you're on your way, and then your integral is 1 over a times the arctangent. It's 1 over a.
1 over a. But
1 over a.
you didn't have to solve it.
Oh, you didn't?
No, it's just that's the integration method.
Oh, okay, cool. And then 2t minus 1 over 2. And then somebody said 19? 19. All right, so 19, I think you did want to find the integral. And we have the integral of v
plus 1 over the quantity 3v minus 1.
like that. All right.
Separated into 2
Yeah, the v part is not going to be an issue. The rest of this,
u equals 3v minus 1.
yeah. So u can be 3v minus 1, and then du is a third dv. What?
So 3.
3?
I got a 4.
God, this is a 4 point for that.
I pointed it
That
out.
was terrible. All right, so yeah, 3. Thank you. And so while this guy is just going to be a half b squared, over here to make this fit, we need a what? A 3 on top, and then a 1/3 out. That's where I was thinking 1/3. We'll go with that. So we'd have 1/3 integral, and then 3 dv is du, and u is getting cubed. So you have u to the negative 3 du. So that becomes u to the negative 2 times negative 1/2, right? So you get negative 1/6 u 3b minus 1 to the negative 2nd power and a half b squared. So you might want to throw that down the stairs because you hate negative exponents because you're a number bigot. And so you have 1/6 and then 3b minus 1 squared like that. So yeah, I was initially thrown off by the, something cubed, but no, it's just a u substitution. It's not too bad. So when you have all these different things running around in your head, it can get jumbled. But if you're not sure and it doesn't immediately fit like an ARCS pattern, think of u sub and what would be a sensible u substitution. Anything else? Dice. That was graceful. All right. 1, 2, 6.
This one is the one.
1. So 1, 2, and 6. Hand it in.
Wait, what? I thought those were the ones you don't laugh.
That's when I rolled 5 dice. I only rolled 4 today.
What? Okay.
I thought it was. I thought it was like what? I thought it was.
Oh, take an experiment.
So 1, 2, and 6.
Wait, it's going to this direction?
Yeah. This is. What is this?
We're already in.
This is the 4th quarter. So this is your first homework for the 4th quarter.
Tomorrow night, homework on after that.
Oh yeah. Speaking of the test,
Next.
I think it should go into the last quarter,
Thank you.
and that way we have 2 grades in the previous quarter for the tests. And since it actually went not too badly, it's not going to be as big of a hit on your grade as I was expecting it to be. So I think put it in the last quarter, and that way we're on a clean slate going into the 4th quarter.
No,
Why don't we just take a vote of break? No one cares what happens. Okay, I care what they. No.
All right, rows 1, 2, 6. So online people handing your homework, please. I got yours. And then Nolan, Isan, you're still row 1.
Wait, so what's gonna go into this quarter? Just the one quiz? Or
We'll have a quiz, and then we'll have all of our AP review material.
The thing that's due next Friday.
So like the thing that's due next Friday. Albert assignments, we'll bring those
oh,
back.
Albert, no.
Yeah, I gotta get back on Albert and
Okay, you know what? Maybe do that. Maybe keep
Wait, we're doing Albert again?
Yeah. Albert
Yeah,
is,
Albert is busy.
well, you know,
Albert and I
a
were
little
not
bit of
friends.
abuse.
No one likes Albert.
Only a little.
It abused my GPA.
A little bit of abuse, not a lot of abuse. Okay, I'll just stop. That's
You missed the whole spot. Not even like a little
Why are we
spot.
always at the
Okay, but no, but come on, are you serious?
Happy now.
You should
No,
have
not.
done twice. I mean,
I mean, if you're not even happy now, then I don't know what to tell you, Olivia.
Well, you just
All
left
right.
Albert, so.
So, example 6, just picking up where we left off. Find the integral of the tangent squared of 2x.
or are we just doing more examples?
So we're just going to run through more examples of integrating weird stuff and seeing how can
We're
we
doing so good.
take what we've learned so far about integration and apply it to weird stuff.
Oh my god. That was so fun.
I don't need math, I have your mom, so. It wasn't that good. Your mom was
That's funny.
What?
That's funny.
Funny's funny.
U equals 4.
Okay. All right. Do we know the integral of tangent squared?
No.
No.
Nope.
Okay.
We know the integral of secant squared. We don't know the integral of tangent squared.
Didn't we try to say this this out?
Yeah, I thought I'd done this.
Yeah, we tried to do it, and you did the math, and we got something.
It's like the sine squared plus cosine squared equals 1.
Yeah.
That's
And then that tangent squared equals secant squared minus 1.
All right, now you're on to something. So if you look at this, you guys okay?
She's got problems.
I know that. So if you look at this, see, I don't know the integral of tangent squared. We know the integral of secant squared and cosecant squared. Those are tangent and negative cotangent respectively. But we don't know the integral of tangent squared. So that's where you come over here and you say, well, since I do know the integral of secant squared, maybe I can turn this thing into something involving secant squared using our Pythagorean identity. So Bethlehem's saying, well, I do know that sine squared plus cosine squared equals 1. That's one of my Pythagorean identities. Can I leverage that into remembering the other Pythagorean identities that involves tangent? So what would I have to divide by in order to get tangent somewhere here? Cosine. So let's divide everything through by cosine squared and your Pythagorean identity. And what is that going to give us for an alternate Pythagorean identity? What's 1 over cosine? Secant squared.
That's a 5, but okay.
You did.
And then you can rearrange your identities however you like to fit your needs. So if you want tangent squared to turn into something else, isolate tangent squared and say that's the same as secant squared x minus 1. Now, there's one other difference between this and what we have. 2x. Well, guess what? Just put a 2x in there. It still works. So sine squared of anything plus cosine squared of the same thing equals 1. As long as the innards here are identical, then the Pythagorean identities still work. So tangent squared of 2x does equal secant squared of 2x minus 1. We're cool. So we can come over here and take this trig identity and transform this into the secant squared of 2x minus 1 dx. And then that we can integrate because we know the integral of secant squared. What's the integral of secant squared? Tangent. What do I need to slap out front?
2.
No?
1? Okay.
1/2 to compensate for the 2 inside. So you could like do a little mini u substitution. U equals 2x. So du is 2 dx, and then you got to divide by a 1/2 on the front. And then the integral of 1 is x. So you look at something like that, it's like, I don't know what to do with tangent squared, but you know your trig identities, or maybe you don't, but you at least remember this trig identity, and you should all know that one. And then from here, you can leverage that into something involving tangent squared by dividing through by cosine squared. So if you ever forget your Pythagorean identities, at least know the main one and know how you can manipulate it to fit the others as well.
Is there another way to do this? Probably not.
I mean, probably there's more than one way to do it, but it would be messier than this. So this is, I think, the least painful way to do it. The integral of tangent? Let's review that. Integral of tangent x dx is, I believe it's a natural log of the absolute value of cosine x plus c, and I think it's negative, right? And if you want to double check that, say your function is y equals negative outline of cosine x.
Remember what chapter this was?
That would have been chapter 4 probably.
Absolute value.
And
Yeah,
this
correct.
right here is chapter 5. So
I don't
what's,
think it's negative.
to differentiate,
I Googled it.
what's the derivative of the inside?
Wait, maybe it is.
What's the derivative of cosine?
Negative sign.
Negative sine. That goes on top. That goes over the original inside, cosine. Negative sine over cosine is negative tangent. And these negatives cancel out and give you a positive tangent. So that's y prime. Hey, that fits. So yeah, integral of tangent is negative natural log of cosine. Yay. You can probably figure this out yourself by turning tangent into sine over cosine and then doing a u substitution where u equals cosine.
Yeah, but
But it's probably better just to have stuff memorized. Flashcards. Anything else with example 6 or related stuff? Or is it
so using that would
using this? Well, you know what? Maybe this, you'd have a very different form of the antiderivative. If you had u equal tangent of 2x,
But that would be what's going on.
then du would be like 2 secant squared. No, I don't think you'd want to do that. All right, example 7, we have 3 different integrals, and it's kind of like what we started off example 1 with a couple days ago. 3 different integrals, they all look very similar to each other. If you're playing along at home, here's the 3rd integral. So the denominator is the same on all 3. The numerator, you have a 3, then a 3x, then a 3x squared. What do you think is your approach for number A?
Sine.
Arc,
Secant.
sine, or secant?
Sine. It's sine.
Sine.
It's definitely not secant.
Definitely not secant. Why not secant?
Because
Because
it
it's
doesn't have
black
the
or
square
white.
root times.
Nothing out front, and even more so, the inside's got to have a positive x and a negative constant for secant. So this is sine. We got this subtracting of the variable part. So this is arc sine. What's our u? X. What's our a? 1, and then we just have an extra multiplier by 3. So when we integrate this, what do we get?
3 arc sine x over 1 squared of x.
Yeah, so 3 arc sine of x over 1, which is x, plus c. So recognize those arc integration patterns. It'll help you, especially on the multiple choice. Question, yes?
But is this also like
Isn't this also what? Is it possible with a u sub, where we have u equal the inside? But then u, if u equals 1 minus 2 minus x squared, the problem with that is that du doesn't equal just negative 2, it equals negative 2x dx. And then we have this x issue. So that's why this is a arc pattern, whereas this is u sub that you're describing, Michaela. So then here you say u equals 1/2 minus x squared, du equals negative 2x dx, and then to make it work, I would probably just pull the 3 out front, but you don't necessarily have to. You need to get this number here to become what? Negative 2. So to make that happen, what do you need to multiply by? Negative 2/3. You multiply by negative 2/3, and then on the outside you multiply by negative 3/2. You keep things balanced. So those cancel out and leaves you with negative 2x dx in your numerator. So when you do your u sub, you have negative 3/2 integral, and then u to the negative 1/2 to u. So when you integrate, u to the negative 1/2 becomes what? 2u to the 1/2, or 2 root u. And remember, u is really 1 minus x squared, and you can multiply negative 3/2 and 2 and get negative 3 out front. Yes.
Can you do the arc secant for an example?
Not in the time we have remaining. But it might show up in the homework. Of the 3 arc situations, from what I've run across, arc secant seems to be the least common of the 3. I don't know why, just I'm sure it'll show up in the homework. We'll talk about it tomorrow. Last one, you look at this guy, and u sub, what might you be your u?
Oh, wait.
Yeah, we're not worried.
1 minus x squared, okay?
And then, so the square root of, wait, what? Oh, yeah, that's e. No, the square root of negative u plus 1 x.
So you say, okay, so you're saying let's isolate the x here to account for the extra x.
Yeah.
So we have negative 2x dx, but there's another x there to deal with. So if we have
Square root of 1 minus.
x squared equals what? 1 minus u, so x equals root 1 minus u. Oh, this is going to be an ugly mess. So we have 3 out front,
Being square.
and then multiply by negative 2x dx. That's going to become du. Then we have an extra x all over the square root of 1 minus x squared. What's happening? I'm making a mess. And then we're dividing by negative 2 to compensate for that negative 2. So we have negative 3 halves integral. That part becomes du. This x becomes the square root of 1 minus u. And the bottom becomes root u.
Why isn't it?
Why would what be u squared?
Because they took out the 3, but the x is still being
So that's
Yeah, then,
x squared. I'm breaking apart into x and x.
but.
2x dx becomes du. And the other x becomes root 1 minus u.
Yeah, when we took out the 3, it was still x squared, so that's.
X squared is 1 minus u.
Yeah. So just regular x is the square root,
Yeah.
so it stays the
So-
square root.
Square root of x is root 1 minus u. That's this other x.
Oh, stop. What's inappropriate?
So then you can integrate.
Yeah. Yeah.
Do that.
That's inappropriate.
I have a feeling that wasn't the right way to do.
But it was supposed to be long.
I'm not sure this is actually
Not wrong,
doable,
but you know.
but I think if it is doable, I think we're on the right
That's fine.
path.
You can have it. You want it?
So do you guys have homework to do tomorrow?
No, I'm
So-
done with it.
Yes.
So do your, yeah, I think it's due tomorrow. But check, whatever it says on school with you, that's what it is.
Okay, Betty, let's do that.
Yes, ma'am.
I did look through the whole test.
Yeah, so I already.
I don't know. So I got 2 points for everything.
Yes.
Oh, no, you almost got it.
I think it was 1 point for the balance and 1 point for the whole.
I thought this was right.
Yeah, everything else is right. I'm trying to tell you what my rationale is. I'm not saying you're good, I'm just trying to get that into my mind. So I think it was 1 point for the balance. Let me get out my key. Are you A or B?
Put my
Thank you. Alright, so which number is this? 7. So it was 1 point for the bounds itself, 1 point for the integram, and then 2 points for the answer as a whole. Yeah. So now because you did it as 1/2 pi, so I was able to figure out that if you had a 1/2 pi out front instead of a 1/8 pi, that was fine. So there's lots of ways to express this. So it was 2 points for the answer, and then within the answer, 1 point for the bounds and 1 point for the integrand. You got your point for the integrand and 1 of the 2 points for the answer as a whole. You didn't get the other point for the answer as a whole and 1 point for the bounds. So the answer as a whole is wrong because you forgot the bounds and then you didn't get the point for the bounds.
Okay, I think I understand.
Yeah,
Okay. And then this was right, I just forgot this.
yeah.
Alright.
You're welcome. Thank you, sir. Yes, sir. I got it.